Thermonuclear core. Every single second, the sun releases more energy than humanity has produced in its entire history. Yet that is not the terrifying part. The real danger is something scientists still struggle to predict, and when it happens, there is almost nothing we can do. We were taught the sun is just a giant ball of burning gas. That is not actually true. The truth is far stranger, and far more dangerous. Deep in the core, the temperature hits 15 million degrees Celsius. The pressure reaches 265 billion times Earth's atmosphere. At that point, atoms are stripped naked, electrons are ripped away. What remains is a screaming hot ocean of bare protons slamming into each other at impossible speeds. This is called the proton-proton chain. 4 hydrogen nuclei collide, fuse, and become one helium nucleus. But the math does not add up perfectly. A tiny sliver of mass disappears, and that missing mass becomes pure energy. Every second, 4 million tons of the sun's own body are converted into light and heat through Einstein's equation. 600 million tons of hydrogen consumed every single second. But that is not what shocked scientists. The core is only 3% of the sun's total volume, yet it produces 99% of all the sun's energy. The density at the center is 150 times greater than water, over 10 times denser than lead. A single photon of light created in the core right now will not reach the surface for another 170,000 years. The sun is so dense that light itself gets trapped inside it. So NASA did something no one thought was possible. They sent a spacecraft to touch it, and what it found changed everything. Parker's Solar Probe. The hottest part of the sun is not its core, it is the atmosphere surrounding it. Somehow, the farther you move away from the sun's surface, the hotter it becomes. The surface sits at around 5,500 degrees Celsius. The corona, the thin outer atmosphere, exceeds 1 million degrees. Scientists have puzzled over this for decades, and they still do not fully understand why. So NASA built something to go find out. On December 24th, 2024, the Parker Solar Probe flew within 3.8 million miles of the solar surface. It was moving at 430,000 miles per hour. That is fast enough to fly from New York to London in under 30 seconds. The fastest object humanity has ever created. At that distance, the sun-facing side of the heat shield hit nearly 2,500 degrees Fahrenheit. Hot enough to melt steel. But just 4.5 inches behind that shield, instruments sat at a comfortable 85 degrees, room temperature. The shield is made of carbon composite foam, 97% air. The whole thing weighs only 160 pounds. Then the data revealed something nobody expected. Parker discovered switchbacks, magnetic fields near the sun that suddenly reverse direction, zigzagging violently through the solar atmosphere. No one had ever observed them directly before. Then in December 2025, the cameras captured something stranger. Not all the material the sun throws out actually escapes. Some of it makes a U-turn. Magnetized plasma launched during eruptions falls back into the sun, reshaping its atmosphere entirely. As of March 2026, Parker has completed 27 close passes, every single one during a period when the sun has been angrier than anyone predicted. But solar flares are not actually the biggest threat. The real weapon the sun fires at us is something far more massive: coronal mass ejection. Most people think a solar flare is the worst thing the sun can do. It is not. A solar flare is a flash of light. It arrives in 8 minutes, and it is over. A coronal mass ejection is something else entirely. It is the sun firing a billion-ton bullet made of plasma directly into space. The energy released is equivalent to 20 million nuclear bombs detonating at once. CMEs happen when magnetic field lines on the sun's surface twist, tangle, and suddenly snap. That violent reconfiguration flings a wall of charged particles outward at speeds up to 3,000 kilometers per second. The fastest ones cross the 93 million miles between the sun and Earth in just 15 hours. Some expand to over 1 million miles wide as they travel. But here's the part most people never hear about. When a CME connects with Earth, it compresses our planet's magnetic field on one side and stretches it out on the other, like a rubber band being pulled. When it snaps back, it dumps energy into the atmosphere. Satellites scramble, GPS degrades, power grids overload, airlines reroute flights away from the poles. Most CMEs miss us. The sun fires them in every direction, and Earth is a tiny target. But one did connect, and it nearly ended everything. The next discovery terrified scientists even more: the Carrington Event. On September 1st, 1859, British astronomer Richard Carrington was sketching sunspots when a sudden flash of white light erupted from the sun's surface. He had no idea what he had just witnessed. Less than 18 hours later, the sky over the entire planet changed color. Auroras appeared as far south as Honolulu, Cuba, and the Caribbean. In the southern hemisphere, they reached as far north as Chile. The light was so bright that people in the northeastern United States could read a newspaper at midnight, not by lamplight, by the glow of the sky itself. Then something went wrong on the ground. Telegraph lines across Europe and North America went haywire. Operators received electric shocks. Paper caught fire from sparks jumping off the wires. And here is the detail that still makes scientists uncomfortable. Some telegraph operators disconnected their batteries completely. The machines kept working. The geomagnetic storm was so powerful that the Earth itself became the power source. The CME that caused it traveled from the Sun to the Earth in roughly 17.6 hours, nearly 4 times faster than average. It remains the most intense geomagnetic storm in recorded history. In 1859, civilization ran on muscle, steam, and copper wire. The damage was contained. But what would the same storm do today? The answer is the reason governments classify this scenario alongside nuclear war: modern blackout. Imagine waking up tomorrow. No internet, no GPS, no electricity, no communication, not because of war, but because the sun decided today was different. In March 1989, a coronal mass ejection that was not even close to Carrington level hit Earth's magnetic field and collapsed the entire Hydro-Quebec power grid. 6 million people lost electricity. It took 9 hours to restore. Transformers were damaged. Satellites malfunctioned. Auroras were visible as far south as Texas and Florida. That was a moderate storm. Now scale it up. A Lloyd's of London risk assessment estimated that a Carrington-class event striking the United States today could cause up to $2.6 trillion in damage. High-voltage transformers are the weak point. They take 12 to 18 months to build and cannot be mass-produced. A severe geomagnetic storm would physically destroy them. Without those transformers, entire regions go dark, not for hours, for months. Hospitals running on backup generators would face fuel shortages within days. Supply chains would fracture globally, even if the blackout is regional. But here is what makes this personal. In July 2012, a CME, as powerful as the Carrington Event, crossed Earth's orbital path. It missed the planet by roughly 9 days of orbital rotation. 1 week earlier, and it would have been a direct hit. The probability of a Carrington-class event occurring within the next decade is estimated between 1 and 10%. And CMEs are not even the sun's most constant weapon. There is something it sends at you every single day. You just cannot see it. Solar radiation. Every second, the sun sends an invisible stream of ultraviolet radiation toward Earth at the speed of light. You cannot see it, you cannot feel it hitting you, but it is rewriting your DNA the moment it touches your skin. UVB radiation is absorbed directly by DNA inside skin cells. It creates specific lesions called cyclobutane pyrimidine dimers. These are physical kinks in the DNA strand, where 2 neighboring bases fuse together in a way they were never supposed to. If the cell cannot repair the damage, the mutation stays. It accumulates silently, and over years, it becomes cancer. Roughly 90% of non-melanoma skin cancers are linked to chronic UV exposure. Not from tanning beds, not from chemicals, from ordinary sunlight. But ultraviolet is not even the deadliest form of radiation the sun produces. During solar flares, the sun releases bursts of high-energy protons that travel at near light speed. These solar energetic particles can penetrate spacecraft walls and damage human tissue at a cellular level. For astronauts on the Moon or Mars, with no magnetic field and no thick atmosphere for protection, a single severe flare could deliver a lethal radiation dose within hours. Earth's ozone layer blocks the worst of the UV, and our magnetic field deflects most of the charged particles. Those 2 shields are the only reason complex life exists on land. But both of those shields weaken during a specific phase, a phase we are in right now. Solar maximum. Every 11 years, something inside the sun changes. Solar storms become stronger, sunspots appear everywhere, satellites fail, power grids become vulnerable, yet no one fully understands what triggers the cycle. Solar Cycle 25 began in December 2019. By October 2024, NASA and NOAA officially confirmed the sun had reached solar maximum. But this cycle did something no one predicted. The original 2019 forecast called for a weak cycle peaking at a sunspot number of 115. The actual numbers destroyed that estimate. Year 5 of Cycle 25 produced 71% more sunspots per day than the same point in the previous cycle. Then astronomers noticed something even stranger. During solar maximum, the sun's magnetic poles physically flip. North becomes south, south becomes north, flares fire more frequently. CMEs become more powerful. In May 2024, multiple CMEs merged in space and struck Earth together. The resulting storm reached G5 severity, the highest level on the scale, the first G5 event in over 20 years. This heightened activity is expected to continue through 2026 before slowly declining. The Sun will not reach its next quiet minimum until around 2030. Parker Solar Probe has been sampling the corona through the entire cycle. The data it collects now, during the Sun's peak fury, will define how we prepare for the next Carrington. But preparation only works on human timescales. On the Sun's timescale, none of it matters. Because the Sun has already decided how this ends. Red giant death. Somewhere deep inside the Sun, the fuel is running out. Not today, not this century, but it is running out. The Sun has about 5 billion years of hydrogen left in its core. When that supply is gone, the core contracts, heats up, and begins fusing helium into heavier elements like carbon and oxygen. The outer layers respond by expanding outward, massively. In roughly 7.6 billion years, the Sun will swell to 256 times its current size. Its surface will push past the current orbit of Earth by 20%. It will shine 3,000 times brighter. Mercury will be consumed first. Then Venus, then Earth will be inside the Sun, but the planet will be dead long before that moment arrives. Within 1 billion years, the Sun will be hot enough to boil every ocean on Earth. Solar radiation will strip the hydrogen from the water vapor. The oceans will never return. The surface will become molten. Nothing alive on this planet today will have descendants that survive it. After roughly 1 billion years as a bloated red giant, the Sun will shed its outer layers and collapse into a white dwarf, a dense core the size of Earth. It will glow faintly for billions of years, but it will never warm anything again. The Sun has protected life on Earth for 4.6 billion years, but it does not know we are here. It does not care about our technology, our cities, our satellites, our civilization. Someday, it will unleash another storm, or it will simply grow too large and swallow everything we have ever built. The only question is whether we will be ready, or whether we will still be arguing about it when the sky turns red.